Alrighty, folks. Today we are going to be talking about ionic bonds. If you look here on our starting screen, you will notice a little kind of video here of a internet sensation from a few years ago called Salt Bay. So this guy was kind of known for finishing his meat with quite a flourish when it came to salt. And the reason that I bring this up is because when we're talking about ionic bonds and ionic compounds, we're talking about salts. And while table salt may be the salt that you are most familiar with, anything that forms an ionic bond is technically called a salt. So you can also think that we're talking about salts today. Alrighty, so I want you to go ahead and set up your notes. Our topic for today is ionic bonding, and our essential question is, how do atoms form ionic bonds? Go ahead and set up your notes and then continue. Our learning target for today is I know how atoms form ionic bonds. All right, so when atoms, we talked about how electrons or how atoms form ions, and this idea that an atom gains or loses electrons in order to form an ion. Well, we also know that those electrons don't just come from anywhere, they come from other atoms. And so this is what's called electron transfer. And we know that metals lose electrons and become cations or positively charged ions because a neutral atom losing a negative charge results in a positive charge because now there are more protons than electrons. Nonmetals, on the other hand, gain electrons, develop a negative charge, and become anions. So you have a neutral atom gain an electron, and now it has more negative charges than positive charges because it has more electrons than protons, and it becomes a negatively charged anion. So that's our basic premise, is this idea of electron transfer. What question does the previous slide answer? All right, so when that transfer happens, you end up with a positively charged and a negatively charged particle or ion. And when you have opposites like that, opposites attract. So the positively charged particle is attracted to the negatively charged particle, and they are stuck together, or you can think of it as they form an ionic bond. So if you have an ionic bond, it is always going to be between a metal and a non-metal. So an element from the left side of the periodic table and an element from the right side of the periodic table. There is a transfer of electrons. One of the elements takes the electron, the other element gives up its electron and is completely transferred. And this results in oppositely charged ions. What question does the previous slide answer? All right, so this results in the formation of an ionic compound. And what we're looking at here is an ionic compound under a microscope. So you're basically looking at something like table salt. And you can see that salt is actually these little crystals. And that is typical of ionic compounds, is that they form these little crystals. If you dissolve an ionic compound into water, it will conduct electricity. So that's another key component. And or if you melt it and it becomes a liquid, it'll also conduct electricity. And ionic compounds also have very, very high melting points. So whereas with a covalent compound, it might melt at room temperature, you have to get to extremely high temperatures in order to melt an ionic compound. What question does the previous slide answer? All right, so folks, I'm going to ask you to go ahead and pause this video and then go ahead and play the video in the Nearpod, and you'll see how not only how hot you have to get an ionic compound in order to melt it, also some unique properties of liquid ionic compounds, such as if you actually melt salt and make molten salt. So go ahead and pause this video, watch the Nearpod video, and then come on back. All right, so I always love that video. I think that's super cool. The fact that the salt actually explodes. It is so hot when it gets into the water like that. All right, so what we're going to do now is we're going to go ahead and we are going to illustrate and diagram how this electron transfer takes place. So I want you to make sure in your notes that you have these four combinations of atoms set up. And now let's go ahead and walk through how they go from separate atoms to a bonded compound. Alrighty, folks, let's go ahead and take a quick peek about how these electrons move when we are dealing with ionic bonds. So let's go ahead and start off by drawing our metal using one color. So I'm going to go ahead and draw my Lewis dot diagram for sodium. Oops, I don't like that size. Let's try that. All right, so we have sodium, and sodium has one valence electron. And we'll draw our nonmetals in blue. So chlorine, and we know chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. All right, so we know that sodium has fewer valence electrons than chlorine, and so sodium is just going to go ahead and give up its one valence electron because it's a lot easier for sodium to give up one than gain 7. So sodium gives up its valence electron, and the result of that is now sodium has a +1 overall charge, and chlorine has 8 valence electrons and has a -1 overall charge. And so you see that +1 and that -1, they balance each other out and results in a neutral charge. And so there is our first ionic bond. All right, let's go ahead now and try the one below it, magnesium and chlorine. So when we do that, we're going to do magnesium has 2 valence electrons, and then chlorine has 7 valence electrons. Okay, now what you will notice is that in order for chlorine to get 8 valence electrons, it's going to go ahead and take an electron from magnesium. So this chlorine is magnetic or is energetically stable because it has a full octet. However, magnesium still has one more valence electron it wants to get rid of. And so we need a second chlorine to come into the picture with its 7 valence electrons. And it's going to go ahead and take this second valence electron from the magnesium, giving this chlorine a -1 charge as well. And this leaves our magnesium with a +2 charge. And so the result is going to be a magnesium ion with a +2 charge and a chlorine ion with a -1 charge and a second chlorine ion with a -1 charge. So we need 2 chlorine anions in order to balance out the one magnesium cation. All right, folks, I want you to go ahead and pause this video and try to do magnesium and sulfur and then lithium and oxygen on your own, and then come on back and we'll go over how to do it correct, or how to do it together. All right, so let's go ahead and draw our magnesium and sulfur Lewis dot diagram. So magnesium has 1, 2 valence electrons, and sulfur has 1, 2, 3, 4, 5, 6 valence electrons. And so what that means is that sulfur needs 2 more valence electrons to complete its octet, and magnesium wants to get rid of 2. So hey, match made in heaven. So right there, you have magnesium give up both of its valence electrons to sulfur, and because magnesium gave up 2 valence electrons, it now has a +2 charge. And because sulfur now has 2 extra valence electrons in its octet, it has a -2 charge. +2 and -2 balance each other out. The overall charge of the compound is 0, so we are done. We only need one of each. All right, for lithium and oxygen, this time let's go ahead and start with oxygen. Well, we can start with lithium. All right, so lithium has 1 valence electron. Oxygen has 1, 2, 3, 4, 5, 6 valence electrons. All right, so that means that oxygen is going to go ahead and take lithium's valence electron. And lithium now has its outer shell is empty, meaning its inner shell becomes its outer shell, so lithium's good, but oxygen still needs one more valence electron. So a second lithium needs to come along here. Oops. A second lithium needs to come along here with its valence electron, and oxygen is going to take that second lithium's valence electron as well. And the result of this is going to be our oxygen now has 8 valence electrons with a -2 charge, and we have 2 lithiums who have a +1 charge because each of them gave up a valence electron and are satisfied with their full outer shell. So there you go, folks. That is how we do a ionic bonding mechanism. Basically, how do we show the electrons transferring? So there. All right, folks. So make sure that you have this in your notes so that you can refer to it, because I do expect you to be able to show how these electrons move in order to figure out what is the charge on these atoms and then what is the ratio between them. What question does the previous slide answer? All right, folks, let's go ahead and take a 4-question ungraded quiz to see how well we understand the ideas of ionic bonding. So go ahead and pause this video, take the quiz, and see how you do. All right, metals form cations or positively charged ions. Which of the following is a property of ionic compounds? Ionic compounds are crystalline. They have high melting points and they conduct electricity. Sodium and sulfur are reacting to form an ionic bond. How many sodium atoms are involved in the reaction? Well, because sodium has a +1 charge and sulfur has a -2 charge, that means that we're going to need 2 sodium atoms in order to result in a neutral compound. Sodium and sulfur are reacting to form an ionic bond. What is the charge on the sodium atoms? That is going to be +1, as I just said. So if you got all of those answered that way, you should get 100%. All right, folks, go ahead and self-assess on a scale of 1 to 5. How well do you understand ionic bonding? All right, folks. So, what I want you to do to, as we wrap up this lecture here, is I want you to do some practice. So, what we just did with moving those electrons around in your packet, you will find a worksheet that looks like this. I want you to go through, and you can see there's different things. So, you're going to start off for 1 and 2. You're just going to do what we talked about, or what we did with the drawings before. And you can actually see 1 is done for you up here, where you show the electrons move. You draw your Lewis dot diagrams. You show the electrons moving, the resulting ions. Okay, so that's what you would draw right here. And then we describe it over here. The atoms involved are lithium and fluorine. Lithium has 1 valence electron, fluorine has 7. Electron transfer from and to each atom. Lithium loses 1 electron, so you see the electron went from lithium, and then fluorine gained it. So fluorine gains 1, and the ions formed would be lithium with 1 plus and fluorine with 1 minus. Okay, so you're going to go through, and different sections are going to have different blanks. So I want you to go through and practice these. These are the concepts that we're going to be talking about on tomorrow's quick quiz. So if you have any questions, please feel free to reach out to your teacher. Have a great day.